All right, number 26, what is the 0 of the graph? That is, reminder, that is the x-intercept. That is when y is equal to 0. So we're going to set this equation given and equal to 0. So we're going to say 0 is equal to negative 3x plus 32. We're going to subtract 32. So that's going to be negative 32 is equal to negative 3x. Divide by negative 3. So x is equal to 32 over 3. Now it'll be a nice number on the test. I just picked a random number. Number 27, what is the y-intercept? So we need to find when x is equal to 0. There's a couple ways you can handle this. You can think about what is the rate of change between these numbers. So looking at the numbers, if I look at this, so these are changing. Our x values are adding 1. So you could look at it this way. So going from 10 minus 7, 10 minus 7, oops, 10 minus 7 gives me 3. So we're adding 3 each time. So our slope here is 3. So if I think about it, if I'm going backwards, so going backwards, if I subtract 7, 7 minus 3 gives me 4. So that means if I go backwards at 1, 4, that would be 1, 4, that would be the next point. And then 0, well, 4 minus 3 would give me 1. So that means my b should be equal to 1. So that's one way of handling this this table. Another way of handling this and solving this would be, we know the y-intercept b is equal to 1. Another way to handle this is to find your slope. We found our slope, we said our slope was equal to 3. Okay, we can pick a point and talk about this in slope-intercept form. So that would be y is equal to 3x plus b. We don't know what the b is. We can find x and y because they were given that here. So I can use that value, 7, 2, or 2, 7. So I can say 7 is equal to 3 times 2, which is 6, plus b. Subtract 6 from both sides. That would give you our b is equal to 1. So those are two different ways that you can handle that. Number 28. Again, if identify the 0 from a graph, that is the x-intercept, where it crosses the graph, x-intercept. The table, number 29, the table shows a list of values. What is the 0 of the function? So kind of similar situation to number 27, except you need to figure out, you're going to have to probably find the equation of the line and then substitute. You can't really go backwards. The value in this equation, if I remember correctly, it actually gives you the same equation. Y is equal to 3x plus 1. I think it's actually the same. I just picked different values. So you would do the same thing that you did to number 27 to find your equation. And then you would say 0 is equal to 3x plus 1. Subtract 1 from both sides. So negative 1 is equal to 3x. That's going to give you x is equal to negative 1/3. So that is your 0 of the function. That's the x value when y is equal to 0. Okay. Number 30, identify the intercept of a system of equations from a graph where they equal each other. So where their intersection is. I'm removing 31 from the test. Number 32, the easiest way to handle this one is actually using a system of equations. Think about what it's saying. It says the larger of two numbers is 4 more than the smaller number. So I'm just going to write the larger of two numbers. So larger is equal to 4 plus the smaller, right? If we let y equal the larger, or let's see, I think before I let x equal the larger. So x equals the larger number, and y equals the smaller number. That would give me the equation x is equal to 4 plus y. Okay. Then it says the sum of these numbers is 74. So x plus y is equal to 74 because we said the larger plus the smaller. Okay, so now I'm going to use substitution, and I'm going to substitute this in for x. So that's going to be 4 plus y is equal to 74. That's going to give me 4 plus 2y is equal to 74, combining like terms. Subtract 4, that gives me 2y is equal to 70. 70 divided by 2 gives me 35. So y is equal to 35. Now, be careful here. Y is the smaller number, so we need to find the larger number. The larger number is 4 plus the smaller, so X is going to be 35 plus 4, which is going to give us 39. And we can double check our answer. We can say 39 plus 35. That should give us 74, which it does, so we did do our math correctly. All right, number 33. Remember the rule solving equations. If a variable is eliminated, if the resulting statement is true, the solution is infinite. And if the statement is false, it has no solution. Number 34. What is the x value in this equation? So the easiest way to handle this is to clear our fractions. I'm going to multiply our entire equation by the common, because 7 and 21. If I multiply, I can clear 7 by using 21, and of course I can clear 21 by using 21 as well. So I'm going to distribute that 21 to all the terms. So this is going to become 21 divided by 7 gives me 3, so that becomes 3x plus 21 times 2 is going to give me 42. That's going to give me equal to 3 times 21 gives me 63x minus 8. I'm going to combine like terms. I'm going to subtract the 3x. So 42 is equal to 60x minus 8. We're going to add 42 plus 8. It's going to give me 50 is equal to 60x. The zeros are going to cancel each other out. I'm going to divide by 60. As you can see, that cancels the zeros there. So x is going to be equal to 5, 6. Number 35, what is the value of x in the equation? We're going to distribute and simplify and solve for x. So this becomes 3x minus 6 plus 4 is equal to 23. Combine like terms, 3x. Negative 6 plus 4 gives me negative 2. It's equal to 23. We're going to add 2 to both sides. That's going to give me 3x is equal to 21. So x is going to be equal to 7. Number 26 is done the same way. So this is going to give me 6x minus 2 is equal to 7x minus 3. And we're going to combine like terms, distribute. So we're going to subtract negative 2 is equal to x minus 3. We're going to add 3 to both sides. So that's going to give me not negative 1. It's going to give me positive 1. So x is equal to 1. Number 37, what is the greatest possible integer? Really, we're just looking to solve for the value. Okay, I know it looks like it's tricky, and I'm trying to trick you here, but really we're just looking for what we're going to solve for x. And whatever that x value has to be less than, then that's going to be, think about what that greatest integer is going to be. So let's distribute. So this is going to give me 2 minus 4 plus 4x less than 3 plus x. We're going to distribute and combine like terms. That's negative 2 plus 4x less than 3 plus x. I'm going to subtract x. So that's going to give me negative 2 plus 3x less than 3. I'm going to come over here so I have more room. I'm going to add 2 to both sides. So that's going to give me 3x less than 5. We're going to divide 3. So x is less than 5/3. Okay, so let's think about what that means. So 5/3 is also the same thing as approximately 1.67. So think about on the number line. Okay, what I mean is the greatest value. All right, so if I have here, this is 5/3, all right? And then to the right of 5/3 is going to be 2. To the left of 5/3 is going to be 1 1.5. So 1.5. Okay, so the greatest value of this is going to be anything in terms of this is going to be something that's less than 5.3. So that, like, I can say the greatest value is going to be like 1.67. You're going to have to look at your answer choice. It's a multiple choice. But I'm just kind of talking you through into working out what that is. Now, this is going to be a nice number. It's not going to be a fraction. So don't get bogged down on the fraction. All right, let's do number 38. Lois rented the car for $97 a week plus 12 cents per mile the car is driven, so that's one equation. And then we want to know what is the greatest value of miles that Lewis can drive the car in 1 week if at most she spent $160. So we're going to write our equation. So that's y is equal to $97. So 97 a week. So 97 plus 12 cents x, because it says each mile. Each, that's your keyword for the variable. Okay. Now, the x represents the miles because it says miles. It's the number of miles. So that means the y is going to represent the total amount of money that she's spending. So if she can only spend at most $160, I'm going to replace the y with 160. That's going to equal to 97. And we can drop the 0. That's fine. 0.212x. Now we can't drop this because that's important. So I'm going to take 160 minus 97. That's going to give me 63 is equal to 0.2x. We're going to take 63 divided by 0.12. That's going to give me x is equal to 525. Okay, so x representing the number of miles. So she can drive 525 miles in that time if she wants to at most spend $160. All right. Number 40, we're going to solve, and we're going to graph this inequation. I notice that both of my terms in my parentheses here are divisible by 2. So I'm going to go ahead and simplify that. So that becomes 39 less than or equal to 5x minus 9 less than or equal to 16. We're going to add 9 to all three sides. So that becomes negative 30 less than or equal to 5x less than or equal to 16 plus 9 gives me 25. We're going to divide by 5, so that gives me negative 6 less than or equal to x less than or equal to 5. And just as a reminder in terms of graphing, just a reminder, so if I have negative 6 over here, I have 0 over here, and negative 5 over, or positive 5 over here, okay? X, be very careful. Think about your graph. If I'm graphing this, I want to take this out because remember, my x values are going to be opposite. So if I take out the negative 6 and less than x, and I switch these terms, so x is going to be greater than negative 6. So that means, and we're including negative 6, so it's going this way. So we're including all of the values that are in between these two numbers. All right, just as a reminder in terms of that. All right, number 40, I had made a mistake, and so I made a change of this. We're looking for all of the possible values that are not a solution to this. So I'm going to solve for x. So this is x minus 3x minus 6 greater than 4. This becomes negative 2x minus 6 greater than 4. We're going to add 6, so that becomes negative 2x greater than 10. That's going to become x is less than negative 5. So let's draw it on a number line, okay? And that's going to give me negative 5 is here, negative 4 is here, negative 6 is here. We are not including negative 5, so we're going in that direction. All right, so negative 5 would be not a solution of the graph. Negative 4 is definitely not a solution of that graph. All right. Negative 10 is a solution, so is negative 9, and so is negative 7. I highlighted them in yellow just so that you know that I changed them. I'm going to go ahead and stop this video, and I'll see you.